My name is Chris Latimer. I'm one of the product managers that works on APIs and API management for Google. So I'm part of the team that runs the Apogee platform. And I've been working on APIs for a really long time. In fact, when I first started off looking at APIs, it was in the context of service-oriented architecture. And we were always having conversations about things like, should we use SOAP? Should we use REST? Which one is better for enterprises? And at the time, the feeling was, SOAP was sort of this enterprise technology, and REST was more something for the Facebooks and Twitters of the world, this kind of novel technology that really wasn't enterprise ready. And so it's interesting to see the changes that have happened over the last 10 or so years, because now APIs are everywhere. You can't really go more than 5 or 10 minutes over the course of a day without using some type of API. Anytime you pick up your phone, it's probably making an API call. So if you checked your social media today, API calls. If you are checking in for your flight to go home, if you're not a local, that's probably an API call. Do things like purchase something online, again, another API call. And so it should come as absolutely no surprise that with all of these critical things that are running on APIs for our organizations, APIs need security. And normally the type of picture that we think of is something like this. So we don't want to have our organization be on the front page of Google News saying, yet another data breach has happened, and now we're responsible for taking this information that our customers have trusted us with and accidentally leaked it out so that hackers now have access to our passwords and our personal information and those type of things. And the natural inclination that we typically have is to do something like this, to lock up all of our data. How can we take our data and our APIs and make them as secure as possible so absolutely nobody can get access to them? But the problem is, if that's our approach to API security, and all of a sudden we've locked things down so much that we can't actually use them, we're going to miss out on all the value of APIs. And so when we're trying to actually build out API security, locking things down isn't the hard part. It would be easy enough for us just to not build an API, and that's the most secure API of all. But trying to foster innovation, allowing the people who can build really interesting things with our APIs, and not putting in place really heavyweight bottlenecks and unnecessary delays while keeping our APIs secure is a much, much harder problem for us to solve. And that's what we're going to talk about here today in this session. So the way that we put this talk together is I went and I spent a lot of time, so in my role I spend a lot of time with customers, and I get a chance to talk with organizations from all around the country, all around the world. And I like to sort of ask them what sort of things they're concerned about. And so what we did is we started off by looking at specific customer examples and how those customers are addressing their security needs. So we'll start off with a pretty basic one. So we have a lot of retail customers that we work with at Apogee. And a lot of times they'll have APIs like this. These are things like store locations and hours. So we're not looking at sensitive information. I mean, we want people to know when our stores are open. We want people to be able to find our store location so they can come to the stores when they're open to do purchasing with us. But at the same time, it's important information. So we probably have these type of APIs attached to our mobile app. We do want to make sure that people, that this API does remain secured so that we don't, so that people can actually use it. So what type of things do we have to be concerned about with an API that's like this? No sensitive information, but yet relatively important. Well, I know that in a security talk, I've done a number of security talks over the years. And one of the things that I've noticed is that if I don't mention TLS, like as the very first thing, and I've got some security people in the audience, you get very nervous that I didn't mention TLS. So I'm going to go ahead and get that out of the way at the beginning, that there are some basic things that we want to do. At this point, TLS is just sort of implied that we're always going to put TLS on top of our APIs. So now that that's out of the way, the other things we have to think about, one customer that I talked with, he put it best. He said, every time I onboard a new application, I've just onboarded a new potential source of a DDoS attack. And that doesn't necessarily mean that people are intentionally DDoSing, but somebody could do something incorrectly. They could build an app that all of a sudden just has more traffic than they were anticipating. And all of a sudden, before you know it, you have floods of traffic that are coming into this API, and they end up inadvertently taking it down. And again, with something like a store locator, that means that if somebody is on your mobile app and they're trying to get access to your store or find the closest store, suddenly that customer can no longer actually come into the store. So we have to think about things like, even with this API that we want people to have access to, we want them to be able to use it, how can we allow them to use it in a way that doesn't introduce unnecessary risk? So traditionally, our approach to this type of problem was to enforce some type of heavyweight governance. So before I joined Apogee and before we were acquired by Google, I spent a lot of time working for a large insurance company. And our approach, whenever we wanted to sort of share data, was very much a matter of picking up the phone or sending an email and saying, hey, I know you have a service. I'd like to use this in my application. And usually the response was something like, great, let's sit down. When can we get together? And you can fill out this 100-question questionnaire about everything you're going to do with my data. And then we'll understand your business justification. And then we'll decide if we're going to give you access or not. And over the course of weeks of getting together and sort of reviewing and security reviews, ultimately you would get access to the API. And for no very good reason, we ended up delaying our ability to actually get something out the door. So a much better approach to this is just to enforce traffic management. There's nothing sensitive about this information. It's just store locations and hours. So what if we could give access to anyone who wanted it, either within our organization or outside, depending on the API you're working with, and say, you can have access to it automatically. We'll give you access to this API. However, we're going to limit that access. So if you wanted to make more than, say, 100 calls an hour or 1,000 calls an hour, or whatever is appropriate, we're just going to start throttling that traffic, and we're not going to give you access. So we don't have to worry about the floods of traffic coming in and inadvertently doing a denial of service. And we can also open up this API so more people can use it. The other traditional approach that we would see is something like a service registry. And in this sense, I'm not talking about sort of the service registries that have come along recently in a microservices-based architecture. I'm talking about sort of the old school service, web service repositories and registries and those type of things, where we would try to keep track of, okay, who has access to this API, and we'll sort of note down who might be the potential source of floods of traffic that are coming in. A much better approach is to automate that. So with platforms, the API management platforms, usually we can do things like issue API keys. And so if we wanted to be able to look and see exactly who's making which calls and how much traffic's coming in, API keys provide us a great way of doing that. Now we have an identifier we can use to track our traffic that's coming through and to enforce those quotas. So we know that as an API call comes in, it has a key, this is the app, this is what the app's entitled to, and we'll start throttling those things right away. The other thing we have to be aware of are content-based attacks. So even though this particular API doesn't intentionally expose sensitive data, somebody may try to get around that. They may try to send in requests that the API is not expecting. Maybe they're doing things like SQL injection attacks or cross-site scripting. And so we want to be able to protect against those miscreants that are trying to send in negative attacks into our API. So this is usually where we start to think about the capabilities of an API gateway and how we can use an API gateway to intercept those calls and to actually enforce rules that will protect against content-based attacks. And even though I don't want to make this a commercial about Apogee, it just so happens that Google has a platform called Apogee that solves all these security problems. And again, if you want to talk about Apogee or you have more questions about your APIs and API security, happy to dive into those details. And again, these are all customer examples that we've talked to and worked with as we put this talk together. So the next API that we talked with, so this is actually an insurance company, and one of the challenges with insurance is that it's a highly regulated business, and so in this particular example, what we had is this insurance company. They have a product that they work with partners. So if you're a Delta Airlines or Southwest Airlines and you want to offer travel insurance, you can't just offer your own product. There are regulations about who can sell insurance in any given state. And so this insurance company that we were working with offered a travel insurance product that these partners could use. And so we were talking with them about the security concerns that they had. So one of the first things that they were worried about is compliance with industry regulations. So they basically said, when we're working with a Delta Airlines or some really large company, they can, of course, dedicate the 6 months required to go through all of these formal approval processes. We can put in place the controls we need to make sure that we're complying with all the insurance regulations. But when we look at the travel industry as a whole, there's a whole sort of niche market. So we have anybody here from India? Seriously? Nobody at all? Oh, okay. Okay, so I work with a lot of people from India, and I've noticed that there are special dedicated travel sites that are just for trips to India, finding like cheap trips to India, the best times to go, and they offer sort of ways to buy this insurance. But these are really small travel sites. They're not on par with the Travelocity or an Orbitz or a Delta Airlines. And these smaller companies, they can't invest the same amount of time and effort. And there are too many of them out there for the insurance company to actually go and sort of invest that time as well. So they said, we'd like to reach these smaller companies, but we're sort of in a quandary here around exactly how we're going to do that. We have to comply with regulations, so how can we help? So the traditional approach was we just wouldn't. We would just work with the companies who could afford to spend the time with us to put together a tiger team that's going to go through, and 6 months later of meetings and compliance and auditors will feel confident that they can sell our products and others can't. So what they found was they can actually they can productize APIs in such a way that they can offer them in a self-service way to these smaller companies. So whereas a large company, in order to do things like actually sell an insurance product, you didn't have the same regulations just to get a quote on an insurance product. So they said, what if we could take our API, our partner API, and we could productize that in such a way that we offer in a self-service automated fashion, anybody can come and offer a quote. And we'll do a revenue share model with them so that we can comply with regulations. We'll be the ones that are actually selling the product, not the partner, but we can offer them a way to still comply with regulations. And in doing so, what they ended up doing was they would enforce fine-grained access control. So depending on who you are and who you were that was coming into their API program, they could say, we're only going to let you see and get access to these very specific pieces of our API, so we can still foster the innovation that we're after, but we're only going to give the full ability to actually sell an insurance product to our big partners who are willing to go through this process with us. And when it came to actually enforcing this at the runtime perspective, what they do is they say, well, great, when somebody signs up, we're going to give you credentials, and you'll use those credentials to obtain an OAuth token. So when an OAuth token comes in, we're going to look and we're going to say, which products do you have access to? Do you have access to the ability to sell the insurance product or just to get a quote on the insurance product? And so in this way, they were able to take an existing API that they had built out for their partners, and they were able to repurpose it in such a way that they could now support a tremendously larger number of partners. Now, one of the last ones that we'll talk about here, so I was working with a large hospital chain, and so they probably have one of the more interesting APIs that I've come across. So what they've done is they have wired up their ICU. So they have very, very sick patients that are coming in. They've got a lot of sensors and sort of information that's constantly flowing back from the ICU. They've got all the patient's medical data, and they're taking that and they're building out sort of a risk assessment. So every day, if you're a physician at this hospital and you have a patient in the ICU, it's going to tell you, here are the patients that are sort of in the most critical state. And here are the things that we've seen that have sort of led to either death or negative outcomes that we should be aware of, and here's sort of a treatment plan. And so you can imagine in this particular case, you're dealing with HIPAA-compliant data, you're dealing with very sensitive PII data, of course, that's coming through, and as a result, they had some really major security concerns. So what should this particular organization be concerned about? Well, this was by far and away their biggest concern. When you're dealing with HIPAA, there are real legal criminal consequences that you can run into if all of a sudden you take a patient's information. In fact, one of the At one of the hospitals that they run, they ended up having some celebrities coming in, and all of a sudden you had sort of people that wanted to, take a sneak peek at their medical records, and ended up finding some people actually in here. So we wanted to make sure nobody ended up here for no good reason. And so one of the things I want to make sure to mention during this talk is that sometimes this approach is absolutely okay. I mean, there are going to be times when we do have incredibly sensitive information that we're working with, and it's going to be information that absolutely does have to be locked down. It's not something we can take lightly, that we can allow just anybody to get access to. And so I don't want you walking away from this talk thinking, this guy doesn't understand our security. We're in the financial industry, and we've got people's bank accounts, so we need to do this. Absolutely. It's really more a matter of, one of the key takeaways here is that it's really a matter of looking at the APIs, understanding the threats, understanding how we can get the API out as much as possible, and recognizing that sometimes we don't want it out at all. So in this case, they had to figure out who's actually authorized to access patient data. So in this case, it was very clear that they had, depending on the patients that you were assigned as a physician, they wanted to make sure you would only see the information for your patients. And so as a result, we had to have a way for these doctors and nurses and other caregivers to authenticate. And so, traditionally, one of the problems we've faced, and especially in sort of the web space, is direct user authentication. And we've seen sort of over the years, we've done single sign-on type solutions and things like that. Whole products have sort of sprung up to solve the SSO problem. And so in API, from an API perspective, we have a similar construct with a delegated identity and user authorization. So a lot of times this will be things like OpenID Connect, where we can allow users to sign in without ever exposing our passwords and our credentials to that application. We can use OpenID Connect and obtain an OAuth token. So this is often what we would call a three-legged OAuth, where somebody will sign in. If you've seen things like sign in with Google or sign in with Facebook, a lot of organizations are building their own sign in with our platform, and then using those in conjunction with API management to send an OpenID Connect request, get back the response, and then exchange that for an access token. And now what we can do is we can identify the end user that's making these API calls, and we can do fine-grained access control checks to make sure that only the physicians and other caregivers that should have access to this particular patient's information have access. One of the other things that they had to think about was auditing. And so they wanted to be able to keep track of who looked at a patient's data. So again, when we're looking at not just from the standpoint of people trying to hack into this account, but just from a auditing and compliance requirement standpoint, a lot of times they would have specific samplings that they would have to do. So they had to go back and prove, you've built this API, and over the course of the last year, let's pick a specific patient, anonymized of course, and let's look at who actually made a request in to get this particular patient's data. And so what they had to do is they had to put in place audit logging, and so we could go back and we could then look and say, okay, great, for this particular patient, who has looked, and let's make sure that they have access to have looked at that. They were authorized to look at that patient's data. So even with all of these capabilities that we've talked about, we can still end up with cases where attackers find a way. And so to talk about that, I want to invite up my colleague, Matt Bloomberg, to talk a little bit about how we would address those.
Thanks, Chris. Good morning, everybody. So my name is Matt Bloomberg, and I'm a product manager focused on API security at Apogee. And as Chris talked about, API abuse is becoming much more common and is predicted to be the most common attack vector in the enterprise space in the next few years. And I'm going to talk about some of the features that we offer to help you protect your APIs from abuse. So just with a raise of hands, how many people currently expose APIs through a web app? It's about 3/4. And how many are exposing APIs through a mobile app? Okay, about the same number. So over the past couple of years, we've seen a significant growth in public-facing APIs, which is a very, very powerful tool that will help you kind of transform your business, but it definitely comes with the responsibility to protect those APIs. And as much as the security tools out there today are great, sometimes abuse can become much more of a concern. So in the enterprise space, customers typically take a multi-layer approach. And they typically deploy a web application firewall, and that does a relatively good job for web, protecting from DDoS and SQL injection, these types of attacks. But they fail to handle the API-specific attacks, which is where Apogee Sense comes in. So Sense leverages API constructs such as API keys and access tokens in the context of the workflow to help identify behavior which is past the WAF layer. So when we analyze information such as the user agent and API key and look at the volume of that traffic with other attributes over a period of time, we're able to detect API abuse and bot traffic that WAFs are not able to detect. So I'm going to talk for a minute about how Apogee Sense works. So we offer what we call a closed loop protection. So this means that we're able to analyze all of the API traffic as it streams across your proxies. And we'll collect this data and run it through our analysis engine, which detects anomalies and abuse. And then our Sense console offers insights about what type of traffic it's observing and allows you to review that traffic and take action on it, including blocking it or flagging it. And we'll talk about that in a minute. So I'm going to walk you through what a common attack may look like. For many customers, there's an expectation of where they operate their business, where traffic should be coming from. So maybe you're selling products online, maybe you're a domestic airline, but you typically know where traffic should be coming from, or definitely where it should not be coming from. And at a glance here, you can see that with the world map is covered in higher than normal traffic from all over the world. So many countries, there may be, you're not allowed to conduct business, but you're seeing a significant amount of traffic. And in the top corner, you can see that the bot traffic has increased by nearly 30% in the near term. So clearly, there's an attack going on in this case. So as we dive deeper to investigate what's going on, we can start by reviewing the API abuse in the detection report tool. So this is where Sense analyzes and lets you act on behaviors that we can see that exceed thresholds that are set in the product. So for example, there's a brute guesser rule, which in this case was violated more than 3,500 times, 3,500 different bots, resulting in millions of malicious API calls. There's a full list of the rules here that you can see and the number of bots that are exceeding those thresholds. So this gives you an overview of the different types of protection that are offered through the Sense product. So in the previous slide, I showed an example of the brute guesser policy being violated, and you see higher than normal traffic that results in errors over a period of time. So that may be someone trying to attempt to log in, or someone, in another example is the content scraper rule, where a very common attack used to scrape products and pricing data. So if you have mobile apps for shopping, those APIs may be, or web apps for the same use case, those may be scraped for pricing, product information, or again, like login APIs and these types of things. So we have these various thresholds and sets of rules that offer protection for those types of attacks. So if we kind of go back to the attack, we can see that all of the API calls were going after the login URI endpoint here. So you can see that the highest value attacks, such as purchasing, payments, loyalty programs, gift cards, and login, are the most commonly abused and require the highest level of protection using tools such as Sense. If we drill down on a specific IP address to investigate further, we can also see that most of the calls, in this case, all of them, were resulting in 401s and 403s, meaning unauthorized access. So this is what triggered the rule in this particular case. So after review, I think we have enough information to make a decision to block this traffic. So Apogee Sense offers you the ability to block, flag, allow, block, or flag the API traffic. So flagging would allow you to add custom metadata to the headers, which may enable you to configure a honeypot or other system to deal with the traffic. You're also allowed to block it at this point to prevent that IP from being able to continue making API calls, or maybe you're running a flash sale or some other scenario where you'd explicitly want to allow this type of traffic, but that's in your control. So as we can see here, once we took action, the malicious traffic stopped, and we're constantly working on adding new methods of detection across our API products. Google is making a very large investment in security, as you may have seen from other sessions at Next. And in Apogee, it's no different. We're making a very large investment working with, collaborating across teams with the broader Google security teams to take the best security features, machine learning, and automation from Google's products and integrate that into the future Apogee API products in the security area, as well as other functionality.